Hi class, we need to take a look at the following section, and this is the continuation of differential equations that are separable. Now, this is what we're going to call a linear differential equation, and it's an equation that you can write in that following form. Now, if the equation can be written in that form, which is in this case 4.16, these are the steps to actually solve it in order to, well, reach the solution the fastest way possible. But one portion of these linear differential equations is that if the p of x is equal to 0, the equation is actually separable. So therefore, going through these steps ends up making the problem extremely long. So if you recognize that the problem is separable, then separate the variables and integrate both sides. And just to illustrate this, I'm going to do one problem where we do it both ways. And let's take a look at example 1. So example 1, I think we already did this one or one very similar to it. And the first step on this one is to recognize that it's actually separable. So what I'm going to do is I'm going to add the 2xy to the third to both sides. And we're actually having now the x squared y prime, and this is equal to 2x y to the third. And let me divide by the x squared. We're assuming that x is not equal to 0. And then same idea with the y's. So let me rewrite it. This is going to be y prime. This is equal to, well, 2 over x y to the third. And then let me divide by y to the third, and let me just take the problem here. In this case, we end up with y prime over y squared happens to be equal to the values of 2 over x, assuming that x cannot equal to 0 and y cannot equal to 0. So we technically divide it by those two variables. Okay, since this one is separable, we can technically just, well, evaluate the integral of both sides. So on the left hand side, just like we did before, this is the integral of y to the negative 2 dy, which is equal to 2 integral of dx over x. So on the left hand side, after we integrate, we're going to get y to the negative 1 divided by negative 1, and this is equal to 2 ln of the absolute value of x plus the constant c. And then let me actually multiply by negative 1. And we're going to get y to the negative 1 this is equal to negative, I'll just leave it as 2 ln of x plus the values of c. And then just to make it into a positive exponent, let me raise both sides of the equation to the negative 1. So that's going to give us the y over 1 over, and I'll just leave the negative on the outside. This is 2 ln of the absolute value of x plus the values of c. I'll just put the negative on the top. So y is equal to negative 1 over 2 ln absolute value of x plus c. This is our solution. We're assuming that, well, technically 2 times the ln of the absolute value of x plus c is not equal to 0, x is not equal to 0, and y is not equal to 0, since we technically solve for both of those. So this is the conclusion that we ended up in a previous section. I think we did this problem or one almost identical to it. But in this case, it's separable. We don't have to go to through the steps, but I do want to rewrite the problem so that you see the new steps. Some of the problems are not going to be separable. So the only way to actually solve them, it's going to be by following the steps here. That's actually it for this one.